In this question, we're first asked to put this data into the scatter graph below. Now, the thing to note is on the length axis, we have got 0, 1, 2, 3, etc. And in between them is 5 boxes. That means that each box is just worth 0.2. So we've got 1, and then the next one would be 1.2, and then 1.4, 1.6, 1.8, 2, etc. Okay? So bear that in mind when we're plotting them. So the first one I'm going to plot is 1 and 3.0, so that's relatively straightforward. Again, it's going to be easier for you to do it drawing than using this stylus that I'm using. 2 to 3.8, so up the 2 to 3.8, so that's one box below 4, as each box is worth 0.2. Okay, and then we'll have 3 and 5.4. Okay, so that's 2 boxes up above 5. 4 and 6, oh, that's nice and easy. Okay, and then 5 and 6.8. That's one box below. 7 and 6 and 8.2. Okay. So all my points plotted. Now, part B of this question then asked me to draw the best fitting line. So remember, your line sort of goes through in the same direction of the points, and you're trying to get the same amount above and below the line. So there's 6 points. So I'd probably say something like that would be good enough. Now on to part C. It wants us to use our graph to estimate the length of the string when a force of 3.5 is applied. So what I do is I find 3.5 on the force axis, which is down here, and then I draw a line all the way up to my line of best fit. Then when it hits the line, then I draw a line, a horizontal line towards the other axis. So there's my line there, and it seems to be hitting about here, which is 5.2, 5.4, 5.6. So I think 5.6 is the length when a force of 3.5. Now on to D, slightly different. It's saying if I had a spring of 6.6 when a force of 4.5 is applied. So let's start at, reverse this one. Let's start at the length of 6.6. So let's put our line in and go horizontal until we get to the line of best fit. So that's 6.6 there. And now we go down. We go down where it met about there. So I would say the meeting point is about 4.5, so I would say yes, as line of best fit gives 4.5.